This week's seminar is going to focus on solutions to equations. It's going to be an extension of what we did last week, but our specific goal will be I can identify if an equation has one, no, or infinitely many solutions. So if you could at this time, get your title written in your notebook and get your goal written down. So the foldable that you will be getting will look something like this. It will be a trifold that will lay out one solution, no solution, or infinitely many solutions. Now, the process of last week for solving the equations is going to be the same. So this foldable is going to will come in handy for you when you're solving equations this way and determining how many solutions they have. So keep this thing with you. If you don't happen to have one, you can see me for one. But this is a big help, so following along with this will ensure that you solve equations correctly. So let's get into the foldable that we have here in our notes for this week. So first we're looking at solutions to equations. And as you may have noticed on the inside of your foldable that you have one solution, no solution, or infinite solutions. An equation, when solving it, can take one of these three forms. What we've mostly been looking at from last week has been one solution. So today we'll introduce no solution and infinitely many solutions. And like I had mentioned before, the process of solving them will be the same. You'll just have one more step determining which type of solution it has. So let's look at one solution. So with one solution, it tells us that only one number works to make both sides of the equation equal or balanced, kind of like these scales that we have here. And we'll look at those in a second here as well. So only one number works. So this is the case where you are going to have, let me just zoom in here real quick, where you'll have a variable equal to a number. If you ever have that, you know that you have one solution to your equation. So there we're zoomed in a little bit more. It can help us out to see things a little bit clearer. So let's look at this equation we have here. We have 4x equals 2x plus 6. So let's look at our foldable, because that will help us out again here. So look at the equation. Are there any grouping symbols? No. We don't have any grouping symbols like parentheses or curly brackets, so that means move to the next step. Look at each side of the equation. Are there like terms on the left side? Are there like terms on the right side? The answer to this one is no as well, because we don't have like terms on both sides that need to be combined. So we move down. We have, do you have variables on both sides of the equal sign? In this case, yes, we do. So let's open this up. It says choose the variable with the smaller coefficient, undo the variable by adding the opposite to both sides of the equation, or just subtracting or adding depending on what it is. So if I look on the right-hand side, I have more going on over here. And if we're moving variables, I need to move this 2x. So right now it's a positive 2x, so in order to undo it, I'm going to have to subtract 2x. Let's rewrite what I have. 4x minus 2x would leave me with 2x, and that's going to be equal to 6, which we still have on the right-hand side. Now, we don't have any constants added or subtracted because we've gotten to this point, so that step we won't need. Does your variable have a coefficient other than 1? Yes, in this case it does. It has a coefficient of 2. So, undo the coefficient of the variable by doing the opposite operation. So in this case we have multiplication because we have a variable next to a number. We need to undo that with division. So divide by 2, divide by 2. 2 divided by 2 is 1, so we're just left with x, and 6 divided by 2 is 3. So our solution here is 3. So let's look at this scale here real quick, and we're just going to balance this out. Remember, in an equation, we want the left side to be equal to the right side. So it's like a balance, like a scale. So what I'm going to do here is just draw the box, because we don't have a number there to put yet, and we have 3 on the right hand side. And in this case, x equals 3 is the only caret that in there, only so x equals 3 is the only possible answer. And the reason for that is, in order to balance the scale, if I'm going to put something in this box, the only thing that I can put here is a 3 for this to be balanced. Same goes for the scale that's up top. In order to balance this, for these boxes to balance out, if I put a 3 in each one of these, I have 12 and I have 12. So 3 is the only thing that I can put in those boxes there in order for this to be balanced. So this is when you have one solution, when you end up with a variable equal to a number. So let's move to no solutions. So what a no solution means is that no possible number can work. So what that means is that no matter what, I cannot find a number that will balance the left side with the right side to put in these boxes. And it needs to be the same number because it would be replacing the variable of x. And if we have x on both sides and we would solve for x, whatever x is equal to would have to go in both spots in this equation. So there's nothing that can balance the left side to the right side, which would leave us with no solution. There's also something else that comes up that can help us determine if it's no solution or the following infinitely many solutions. So let's solve this problem here real quick. Take out our trusty foldable. So look at the equation. Are there any grouping symbols? No, we don't have any grouping symbols. Look at each, so we're moving to the next step then. Look at each side of the equation. Are there like terms on the left side? Are there like terms on the right side? No, there's nothing on the left side or right side that we have to put together before we can move forward. Now it says here, do you have variables on both sides of the equal sign? Well, yes, we do. We have x on both sides. So open this up, read yes, choose the variable with the smaller coefficient, undo that variable by adding the opposite to both sides of the equation. So in this case, we have a coefficient of 1 with both, so it doesn't matter which one we move. So I'm going to move the one that's on the right-hand side. So since I have a 1x, remember there's a 1 there, I'm just going to subtract x to get it over to the other side. So we've taken care of that. Let's see what happens here. If I have x minus x, that gives me 0. So we don't have that x there anymore. That's eliminated. So I'm only left with 3. Put my equal sign. If I look here again, this x minus x, that's 0. We can't do that. Well, we can do that, but we won't have a variable anymore. So we end up with 3 equal to 5. Now, can 3 ever be 5? 3 ever be equal to 5? Can it balance it? Well, the answer there is no. So these are not equal to one another. So one thing that we can kind of determine to narrow down what type of solution it is between no and infinitely many solutions is that all variables are eliminated. All variables are eliminated here. So that narrows it down to our no solution and infinite solutions. But the only difference here is that 3 would not balance 5 on a scale. So there's no solution because the scale is not balanced. So if you end up with one number equal to another number that's not itself, we know that there's no solution, and all variables will be eliminated. So there's no value of x that we can put in either one of these boxes to get both sides balanced. So that's why we have no solutions there. And last but not least, let's take a look at infinite solutions, or infinitely many solutions. And in this case, all numbers can work. So what this is saying is that no matter what I put on either side of this scale, it's going to balance out. So if I would put a 3 in there, I would get 7 on both sides. If I would put a 10 in there, I would get 14 on both sides, so on and so forth. But we want to look at that algebraically and what's in this equation here. So let's go ahead and solve this. You want to run through your foldable again here, so this will be helpful. So grouping symbols, no. Like terms on the left and right side, no. Variables on both sides of the equation, yes. So we need to subtract them again, kind of like in the no solution part. This time, well, it really doesn't matter because we're subtracting them. So as long as you're getting rid of it from one side or the other, because we don't have a coefficient that's smaller, they're both 1. So we've taken care of that. So let's write what we have. So these cancel. These also cancel because a 1 cancels out a negative 1. That's 0. So I end up with 4 being equal to 4. Now, is 4 equal to 4? Well, I'd hope that you answer yes, because 4 is always equal to itself, no matter what. And if you notice here again, all of our variables are eliminated. The only difference here is that now we have a number equal to itself. And this tells us that there's infinitely many solutions. And like I mentioned earlier, what that tells us is that no matter what number we put in here, this scale is going to be balanced. So kind of like down here then, if I'd put 4 here and 4 here, I would end up with a balanced scale. So we can say infinite solutions because scale is balanced. The scale is balanced here. So just a quick recap. With one solution, you have a number equal to a variable, and there's only one possible answer that you can put in to balance the scale. With no solution, there's no possible answer that you can put into either side of the equation or on either side of the scale to balance it out. All variables are eliminated. You'll end up with a number equal to another number, which never can happen. So that signifies no solutions, and the scale will not be balanced. And infinite solutions because all numbers can work. You'll end up with a number equal to itself. All your variables are eliminated, and no matter what you put on either side of the scale, in for this box here, or whether it's down here, it's always going to balance. So infinite solutions because the scale is balanced here. Now the 3 equations that I have set up are fairly simple, fairly easy to work through. They can definitely vary in complexity, So be prepared to work through your foldable. Some are going to be a lot easier than others to spot, whether it's one solution, no solution, or infinite solutions. Remember, just take your time, slow down, work through this foldable, as this will be a great help to you. And that basically sums up what solutions to equations are. You can have the one solution, no solution, or infinitely many solutions. So make sure that this foldable gets put into your notebook. Be a great reference, not only for solving equations now, but in the future when we get into other topics, this will come in handy. And then just a quick recap of what our goal was today. Remember, we were looking at solutions to equations, and our goal was I can identify if an equation has one, no, or infinitely many solutions. So hopefully after watching this video and completing the foldable for your notebook, you're well on your way to understanding the different types of solutions that there can be to equations. As always, if you have any questions, please feel free to ask me.